Okay, so we're here with Jim Metcalf. He's about to give us a quick tour of the helium lab at UC Boulder.
All right, so all the uranium, thorium, helium dating we're doing for this project is going to be done starting with this machine here, which is called an Alphacron. That's the brand name. It's made by Australian Scientific Instruments. And what it is a helium extraction and analysis machine. It's made up of a few components, and it looks very complicated, but it's actually relatively straightforward. What we do is we load our samples in here, and I'll show you that in a little bit more detail in a second. This is a chamber, a vacuum chamber. The noise you can hear in the background, the whirring, those are a bunch of vacuum pumps. We have 3 on this line, and what it does is it keeps the interior of the line, so the insides of these tubes, at an ultra-high vacuum, which is about a 10 billionth of atmospheric pressure. So we load the samples into the vacuum chamber. It's difficult to see, but Al, if you can come around, there's a red cable that goes in the back there. What that is a fiber optic cable that carries a laser on it. So the samples are loaded into the vacuum chamber, and then they're heated with a laser to degas all of the helium out of them. We heat the samples up to about 1,000 degrees for anywhere from 5 to 10 minutes to degas them. The gas then expands into the vacuum. All of these black things here are just valves that allow us to control where the gas goes. We have a couple things here that are called getters, which allow us to clean up the gas. And then in the back, that red box there is a mass spectrometer. It's just a really small quadrupole mass spectrometer.
Wow.
It turns out that measuring helium isotopes is relatively easy, so we don't need a really powerful thing to do it. The way that we measure the absolute amount of gas is with a technique called isotope dilution. So underneath the table there is a tank of pure helium-3, the isotope helium-3, which is the rare isotope of helium-3. It's one of these shiny tanks over here.
Okay, got them.
The helium that comes out of our crystals is helium-4. So what we do is we spike the unknown amount of helium-4 in our crystals with a very precisely calibrated known amount of helium-3. Let the gas mix, and then when we measure it on the mass spectrometer, we can tell the exact number of atoms of helium-4 that are trapped in our crystal. So we do single crystal analyses on this line. So what I have here is one of the samples that I actually degassed last night. It's hard to see, but inside of this tube is a tiny niobium metal packet. It's about 1 millimeter long and about 3/4 of a millimeter wide. And what we've done is we've loaded one tiny zircon crystal that is maybe 150 microns long into this one little niobium packet. Each one of those packets is put into one of these little holes in this sample planchette, and all these little numbered holes. Then this sample holder is loaded into the vacuum. The way that this machine works is that the stage that the vacuum chamber sits on is automated, so we can tell it to go to a specific hole, heat it with a laser for a specific amount of time, and measure all of the gas. So this is the first stage in the whole process of measuring the helium amount. Of course, in the dating technique, you need to know both the daughter, which is the helium, and the parent isotopes, and I can show you where we measure the parents next.